Today we're going to be looking at double argument properties. We're looking at arguments that are double a trig value, and we want to write it in terms of the trig value. So we have cosine of 2x, or sine of 2x here, and cosine of 2x over here. Now the question is sine of 2x equal to 2 sine of x? So let's just look at an example. If x is pi over 2, we know that sine of pi over 2 is equal to 1. We also know that 2 times pi over 2 is pi. So in other words, the sine of pi equal to 2 sine of pi over 2. Well, sine of pi is 0. So this is saying 0 is 2 times 1. Clearly not. So we know that sine of 2x and 2 sine of x are not equivalent to each other. All it takes is one example to show that that's not true. So how do we write sine of 2x? Well, we're going to turn to our composite argument properties to figure that out. We're going to rewrite sine of 2x as sine of x plus x. In other words, two angles added together. They just both happen to be the same angle. And so we're going to apply our property for sine of a plus b. When in this case, though, both a and b are going to be replaced by x. So we remember, hopefully, that this is sine a cosine b plus cosine a sine b. And I'm going to use that property here and say this is sine x cosine x. Remember, a and b are the same thing, plus cosine x sine x. And this could also be written sine x cosine x plus sine x cosine x. Because these two are multiplied together, I can switch the order here. So that's just 2 times sine x cosine x. So we're saying sine of 2x is equal to 2 sine x cosine x. That's our first property. And we could double check it with what we tried up here. So we're saying that if, for example, if x is pi over 2, sine of 2 times pi over 2 is equal to 2 times sine of pi over 2 times cosine of pi over 2. So sine of pi is equal to 2 times 1 times 0, and this is 0, so 0 equals 0, correct. Now that's just one example. One example doesn't prove that the property already works. The reason we know it always works is because we proved it from a property we already proved from something else. Anytime you prove a property works using just algebra and geometry techniques, and then you can prove something else from a previous property, mathematically we know that it's always going to work. So there's our first double argument property. Now we're going to do the same thing with cosine. Cosine of 2x can be rewritten as cosine of x plus x. And we're going to apply the property that says cosine of a plus b.
Pardon the interruption. I need all track members to be dismissed.
Pardon the interruption here. So this is cosine x cosine x minus sine x sine x. Gotta love the announcements there on the speaker. So this is cosine, this would be cosine squared of x minus sine squared of x. Now don't mix this up with cosine squared of x plus sine squared of x. That equals 1. This is cosine of squared of x minus sine squared of x. So that is our second property. It might be interesting just to try this with an angle that's not a special angle. So let's go on the calculator here. So we can see here cosine 40 is 0.76044. Cosine of 20 squared minus sine of 20 squared is also the same thing. So just picking an arbitrary angle, I happen to be in degrees. I use degrees in here that work the same for radians. Okay, so let's go back now. You'll notice that there are two other things on your property sheet that say cosine of 2x. And it turns out there's two other ways to write cosine of 2x. Sometimes it's helpful to be able to find cosine of 2x when I only know either sine or cosine. I don't need to know both of them. So we're going to use the Pythagorean property. We have a property that says sine squared x plus cosine squared x equals 1. By rearranging this, I could say that sine squared x equals 1 minus cosine squared x. And I also could rearrange the first one to say cosine squared x is 1 minus sine squared x. So I'm going to substitute first one of these and then the other into this function to rewrite the function in terms of only sine or only cosine. So first I'll start with the first one. I'm going to replace the sine squared x with 1 minus cosine squared x. So I would get cosine squared x minus 1 minus cosine squared x, which would be cosine squared x minus 1 plus cosine squared x, which is 2 cosine squared x minus 1. So another way to write cosine of 2x is to write it as 2 cosine squared x minus 1. Now I'm going to take the second one right here and substitute it into here. And when I got this first one, I got this, and then I'm going to substitute cosine squared x is 1 minus sine squared x, and I'll get another form. So going back to the original here and rewriting this again, I have cosine of 2x is equal to, and I'm going to substitute now 1 minus sine squared x for the cosine squared, minus sine squared x is going to give me 1 minus sine squared x minus sine squared x, which is equal to 1 minus 2 sine squared x. So cosine of 2x can also be written as 1 minus 2 sine squared x. Now if we look at the three different ways to write this, I want you to notice how they change. The first one is just like the Pythagorean property, only with a minus instead of a plus. Then we double the first one and change the second to 1. Then we change the first one to 1 and double the second one. So these are how these three are related. Now the last two then are going to be used to find the last two properties, which is what does cosine squared of x and sine squared of x equal. So now I'm going to take this property and I'm going to say, let's solve that for cosine squared of x. So I could write cosine of 2x plus 1 is equal to 2 cosine squared of x. So 1/2 times cosine of 2x plus 1 is equal to cosine squared of x. So this is another property, and what's useful about this, particularly in calculus, is that it's easy to take the cosine of 2x. It's not as easy to take it's easy to take the derivative of the cosine of 2x, not so easy to take the derivative of cosine squared of x. So I can write cosine squared of x in terms of just cosine, an unsquared cosine function. It's a lot easier to work with in calculus. So that property then is cosine squared of x is equal to 1/2 cosine of 2x plus 1. So there's the fifth property. And then the last one is sine squared of x. So now we're going to take this one right here and rewrite and say, let's solve that for sine squared of x. So I'm going to add 2 sine squared of x to both sides, giving me a positive 2 sine squared of x on the left-hand side of the equation, and subtract cosine of 2x from the left-hand side, giving me 1 minus cosine of 2x on the right-hand side. So hopefully you can see what I did there. Add 2 sine squared of x to both sides, subtract cosine of 2x from both sides, and then just multiply by 1/2, and I get sine squared x is equal to 1/2 times 1 minus cosine of 2x. And I guess usually when you see this written, it's usually written with a 1 first, 1 plus cosine of 2x and 1 minus cosine of 2x. So maybe that might be a better way to write it as far as putting it on your property sheet. 1/2 1 plus cosine of 2x. So then they kind of look more alike. So notice the only difference between them is for the cosine you're adding here and for the sine you're subtracting. So those are the last of the properties that I want you to be able to know. And then we'll talk a little bit more in a different video about how to apply the properties.